Hello, students! In our last class, we learned all about acids and their chemical reactions. Now, you might be thinking, what about bases? Do they also react? Well, that's exactly what we are going to explore today. We will look at the chemical properties of bases and also of oxides. So, let us begin. So, to start, let's ask this question again. We have spent a lot of time learning that acids undergo many chemical reactions, but what about bases? Do they react as well? The answer, of course, is yes, they do, and today we are going to learn about some of their most important reactions. Okay, so for our first section, we are going to look at the reaction of bases with metals. This is a very important reaction, and we will understand it with the help of an activity from your textbook. Now, let's go through the steps of this experiment, which is Activity 2.4. First, you will take a few pieces of granulated zinc metal in a test tube. Then, you will add about 2 milliliters of sodium hydroxide solution to it. After that, you need to gently warm the test tube. As you warm it, what will you observe? You will see that a gas is being formed. And when this gas that is formed is tested, we find that it is hydrogen gas. Now, does this sound familiar to you? Think back to when we learned about the reactions of acids. When an acid reacts with a metal, what gas is produced? Yes, it is also hydrogen gas. So this is a very important similarity. So, from this observation, we can write a general reaction. Whenever a base reacts with a metal, the products will be a salt and hydrogen gas. Please remember this general equation. Base plus metal gives salt plus hydrogen gas. All right, let's move on to our second section. Here, we will look at what happens when a base reacts with an acid. This is a reaction you may have heard of before. It is called neutralization. Let's take a simple example. We can take a base, like sodium hydroxide, and react it with an acid, like hydrochloric acid. When we mix them, something very interesting happens. The effect of the base is canceled by the acid, and the effect of the acid is canceled by the base. They neutralize each other.
And this type of reaction, where an acid and a base cancel each other out, has a special name. It is called a neutralization reaction. And what is the definition? A neutralization reaction is the reaction between an acid and a base to give us salt and water. It is very important to remember the products.
So, once again, we can write a general reaction for this. Base plus acid will always give you salt plus water. This is a pattern that you will see again and again in chemistry, so please make a note of it. Very good. Now that we understand how bases react, let's talk about a related group of compounds. We will now learn about metallic oxides, and we will see why they are sometimes called basic oxides. So, to understand their nature, let's ask a question. What happens when we react a metallic oxide with an acid? For our example, let's take a metallic oxide called copper oxide and see how it reacts. Now this comes from Activity 2.7 in your book. When you take a little black copper oxide and add it to dilute hydrochloric acid, you will notice a change. The black solid will dissolve and the color of the solution would change to a blue-green color. This color changes are proof that a chemical reaction has taken place. And this reaction also follows a general pattern. The general reaction is metal oxide plus acid gives you salt plus water. Now, I want you to look at this reaction carefully. Does it look similar to another reaction we have just discussed? Think about it. I hope you have noticed the similarity. This reaction produces salt and water, just like the neutralization reaction between a base and an acid. And because metallic oxides react with acids in the same way as bases, we can conclude that they are basic in nature. That is why they are called basic oxides. So, we have learned that metallic oxides are basic. Now, it is logical to ask, what about non-metallic oxides? That is what we will explore in our fourth section. Let's find out about their nature. So the question is, how do non-metallic oxides behave? To find out their nature, we should see how they react with a base. It's the opposite of what we did for metallic oxides. For this, we can recall an observation we have already made in Activity 2.5. Remember the reaction between carbon dioxide and calcium hydroxide, which is lime water? Carbon dioxide is a non-metallic oxide, and calcium hydroxide is a base, and they reacted to produce a salt and water. So, what can we conclude from this? A non-metallic oxide is reacting with a base to give salt and water. This is exactly how an acid reacts with the base. Therefore, we can say that non-metallic oxides are acidic in nature. It is their behavior that tells us this. Okay, students, we have learned quite a few things today. So to make it all very clear, let's quickly summarize all the reaction patterns that we have discussed. This table summarizes everything for you. First, a base reacts with a metal to give salt and hydrogen gas. Second, a base reacts with an acid in a neutralization reaction to give salt and water. Third, a metal oxide reacts with an acid to also give salt and water, which shows us that metallic oxides are basic. And finally, a non-metal oxide reacts with a base to give salt and water, showing us that non-metallic oxides are acidic. This is a very useful summary for you to revise from. And now, to end our class today, I will leave you with a question to think about. We have seen that acids and bases are opposites, and they react with each other. But is there anything that is common to all acids? And is there something that is common to all bases? Think about this, and we will discuss the answer in our next lesson. Thank you.